Hello, boys and girls. The next question on the previous page, which was page 328, question 10, is a word problem. We can look at that in class and discuss why it might be more than or less than. But for now, let's take a look at this grid. Okay, we want to follow the pattern. But what I recommend doing is taking a look at this grid paper that we have here. We want to make a box. Okay, and we have two different dimensions. We have along the side, we have 22 from here to here. We have 22 centimeters. Okay, and from here to here, we have 16 centimeters. But we want to make a box out of this paper. In order for us to make a box, we have to cut out these little corners right here. Cut out one little cube, 1 centimeter on its width, and 1 centimeter, actually 2 centimeters, one here on the length, and 2 centimeters on the width. And that happens. So each dimension loses 2 centimeters. Because what we'd like to do is take this column here, as well as this row, and fold it up, as well as this one and this one. And we're going to fold them up, and that'll be our new little wall. So it's giving us a dimension now of 14, as you can see here. Okay, now it's going to be 14 from there to there. Okay, and from here to here, it will be 20 when we actually glue up the walls. I hope you're able to follow. Well, the purpose is to make a box that will give us the maximum amount of volume. Okay, the highest possible, greatest possible volume. In order for us to have more volume, we have to have higher walls, which means we'll have to continue to cut out these pieces. Okay, let's take a look here closer. We'll have to cut out a little bit more. So I'll have to take one more out from the width and one more out from the length, and cut out more and cut out more. So now I'll be folding up 2 columns, and I'll be folding up 2 widths. Columns, 2 lengths, and 2 width. Now I folded it up so my walls on each side, this one's folded up, this one's folded, folded, and folded. Now I have this wall, and this wall, and this wall, and this wall, and they're higher. Well, if I've done that, take a look at my new width. It goes from here to there. And my new length goes from here and stops there. Okay, so what would be my new length? If you've been able to follow this illustration, you should be able to know now that we are reducing in size. Let me just get rid of this. If I want to fold up the walls, what's going to happen is I have to take 1 centimeter away from each side of the length of my base. So that's going to give me a new, oh, what happened there? Let's see. There. That's going to give me a new length to my base of 18 because I've had to cut 1 on each side, as well as I had to cut 1 on each side on my width. So that's 12. And that's going to give me a new volume. Height times length times width will give me a volume of 432 centimeters cubed. Okay? Continue to build up the walls on the side, or reducing 2 each time, because now if I have 3 centimeter walls, it means I've taken from my length, I've taken 1 from each corner to be able to fold it up higher, and 1 from each corner on my width to fold it up higher. Okay, and that gives me a new volume of 400. Oh, oops. Gives me a new volume of 480 centimeters cubed. Well, continue to play with that. Find the pattern, fill these out, 4, and then minus 2 here, and give me the new volume until you find the highest combination of numbers that will give you the best volume, the greatest volume. On the next page, we have to multiply dimensions that are fractions. As you can see here, we have our width is 1, 2, 3 and a half. And our length is 1, 2, 3, 4, 5, 6. So it's 6 times 3 and a half. Go ahead and try that. And as you move down, you will notice that we have to multiply fractions. So here we have a square with 3/4 and 3/4. Simply multiply the fraction. 3/4 times 3/4. Okay? Will give us 9/16 inches squared. And we will check these in class. See you then.